And to finish up this unit, let's do a bit of a harder problem of nonlinear inequalities. This time, well, the goal is still the same. We have to isolate the x, but that x has three elements on the left side of the inequality. It has the -1, it has the 3 multiplying, and it has the exponent. And we're going to move them exactly in that order, starting with the -1. We already know the inverse operation of a -1 is a +1. So the ones cancel. We must also do +1 on the right side of the inequality. Then 47 plus 1 equals 48. Now we take care of the 3 multiplying the x. The opposite of a multiplication is a division. So the 3's cancel. But that means we also have to divide the 48 on the right side by 3. And 48 divided by 3 gives us 16. So x squared is smaller than 16. And now that we have the x squared by itself, let's clean this space so we can take care of the next step, which is taking that squared and moving it to the right side of the equation. And what's the right? How do we do it? What's the opposite operation of that x squared, as we have been practicing in this entire unit? Is a radical of 2. So the radical cancels with the exponent because they are both 2. But then we must also do it on the right side. Square root of 16. And the square root of 16, well, the square root of 16, if we put in the calculator, is going to be equal to 4. But that's an even index. That's an index of 2. If it is an index of 2, it means we have to consider both the positive solution, so x is smaller than 4, and the negative solution, so x is smaller than -4. And now that we have the two solutions, that's the part where we switch the inequality sign for the negative solution. This step is important. So we take a look at the negative solution, the x is smaller than -4. We grab that inequality sign and we switch it as position of direction. Now x is greater than -4. And since we have our two possible sets of solutions, let's now use the number line so we can graph them and we can understand better what our answer is. So let's start with the x is greater than -4. Generally, it's easier to start by graphing the negative, generally, but that's user's choice. Let's bring our number 9 with the -4, and the x is on the open side of the sign, meaning x is greater than -4. So x could be any number to the right of that -4. Possible solutions are -2. We could have 0, 36, 6,784. What about -4 itself? It is not included because x is greater than -4. It does not include the little line on the bottom of the equal sign. So we take away the -4. Then we take a look at the other solution. X is smaller than 4. We locate the 4 in our number line. X is on the close side of the inequality sign, reaffirming what we said, x is smaller than 4. So we put a line to the left of 4. We made the line red and a little bit above so we can differentiate it. So we can see the orange line represents x greater than -4. The red line represents x is smaller than 4. So what are the possible solutions for the red line? 1, -3, -57, -582. What about 4 itself? One more time, it does not have the little equal sign on the bottom, so we do not include 4. Now we have to better analyze this solution set, better understand what are the actual possible solutions, because if we take a look at the red line and the orange line, technically they cover the entire number line. So what is our actual set of solutions? In these situations, our set of solutions is represented by the intersection of the two lines. So anything inside of that rectangle is our set of solutions. Meaning we have to delete the lines outside of the rectangle. And this is our solution set. Any number bigger than -4 but smaller than 4. So any number inside that small interval.